Okay, good morning, everyone. Today we will continue discussing the white box testing. Let's review white box testing, if you like, for a few minutes. We were talking about the two types of testing since about 3 weeks, about 2 weeks actually, and we mentioned first, we discussed in detail the black box testing first, and which we emphasized is a functional testing, which tested the functionality of the software product, and we further said that what it is based upon is the software specification document. That is, it tests the functionality of the software product or its components using or based upon the software specification document. It compares the actual products of the actual results of the or outputs of the software product against the expected results based upon the software specification document. And then we started discussing the white box testing, which we said is a structural testing, and we emphasized that while it is not required, the software the code is not required in the black box testing, since it's a functionality testing. It is certainly an inevitable component of the code is the inevitable component of the white box testing, since the testing is on the structure of the software product, which is defined and given in detail in the code, in the source code of the software product. Okay, then we gave this example to show you how important it is and how useful it is to go with the white box testing. We have mentioned that we have given this example, shown this example about adding numbers, adding integer numbers up to a value of x. I'm sorry, I. Let's say this one here, and then we added this this part, which is not expected, as a matter of fact, while we add numbers up to a specific limit, which is given here in this example I. And we said that with the black box test cases, while we cannot discover this erroneous line, this erroneous portion of this code with the black box test cases, which is actually I is equal to 10, and it results in failure. With the white box testing, using the white box testing, we can easily get this because, well, because of the, let's say, where was it? Okay, because of this availability of the code, which also takes this I is equal to 10 into consideration. Well, then we continued here with the flow graph. We started with the white box testing principles. We talked about the execution path. We first defined some concepts that we will use in the white box testing, and These were execution path, control flow testing, data flow testing, control flow graph, data flow graph, and the concept and important essential concept of coverage. And then we we actually defined the different flow graph structures, a statement sequence or statement block, decision structures, the conditional if structure. We have mentioned while do loop, do while loop, the for loop, switch case statement. And then we started with the control flow testing, which where we discussed the concept of coverage in detail, where the details were statement coverage, branch coverage, and then we talked about the loop testing, and we further said that the discussion about the concept of coverage will continue with the path coverage, with the condition coverages, multi-condition coverage, etc. Then we defined the execution path. We defined it such that a sequence of nodes and connecting edges from the unique begin node of the flow graph to the unique end node of the graph. Then we said that each path defines a certain instance of the relevant program execution. And it further may contain, we said that it may contain the same node several times, where we introduced the concept of loops. Okay, these were graphical examples about the paths. We said that we have paths here, examples of paths, like this one is a path, this one is another path, and this one here is another path. And we also mentioned the concept of independent paths. We said that this is an independent path, this here is another independent path, and this here is another independent path. And okay, and then we gave the definition of the statement coverage as a specific version of the coverage concept, and we go into some formal definition, where we said that a set P. Okay, let's repeat this the definition of the statement coverage criterion. A set P of execution paths satisfies the statement coverage criterion if and only if for all nodes n, by a node we mean such a statement here, okay? If and only if for all nodes n in the flow graph there is at least one path P in the set of execution paths uppercase P, such that P contains the node n. That means each statement of the program is executed at least once during testing by some test case. So if this criterion is met, then we're talking about a complete, that is 100% statement coverage. If the criterion is not met, then we say that the statement coverage is fulfilled only partially, which shows us a smaller percentage than a complete coverage. Here, in the when we talk about the nodes here, we exclude the begin node, the end node, and the junctions. Okay. Well, we will in the coming discussion, in the discussion of the independent paths of the computational complexity, you will see how we will behave, how we will treat the begin node, end node, and junction exceptions. Okay. Then we further defined. The branch coverage criterion. Here we said that a set of P, a set P of execution paths satisfies the branch coverage criterion if and only if for all edges E in the flow graph, there is at least one path P in P such that P contains the edge E. That is to say, each control flow branch decision is taken at least once during testing by some test case. So again, we said that if this criterion is met, if each edge is at least contained in a path, execution path P, while we perform white box testing, then we say that the criterion is met completely. That is, we are talking about 100% branch coverage. But complete branch coverage means complete statement coverage. I will show you on a flow graph too in a minute how this is so. But this means that the complete branch coverage means complete statement coverage is to say that branch coverage subsumes, it contains, it includes statement coverage. That is, if branch coverage is complete, then that means we have a full percentage, 100% statement coverage. Well, usually more tests are needed for complete branch coverage than needed for the complete statement coverage. And that's why we say that branch coverage subsumes statement coverage. And branch coverage is more extensive. Well, these two, complete branch coverage means complete statement coverage. And the third remark, usually more tests are needed for complete branch coverage than needed for the complete statement coverage. That they both show us or imply that branch coverage is more extensive than the statement coverage. That means that further means that the branch coverage is a stronger criterion than the statement coverage criterion. Well, in this case, of course, if the branch coverage criterion is not met, again, we have a partial branch coverage, not a 100% branch coverage. Okay. Now, let me show you how we have a full statement coverage once we have a complete branch coverage. Well, look at here, for example. In the statement coverage, well, we covered this one, plus we covered this one, okay? Well, using these two paths, okay, we have a full statement coverage. You can see that, right? Because using this path, each of these statements, including the yellow decision statements or if statements, each of these statements are covered at least once. So this execution path covers all statements here. Okay? This is important now. And this second path covers all these statements above, that is 8, 9, 10, and 11. These statements are also covered in the second execution path here. So using these two paths, this one and this one, we have a full statement coverage. Do you agree with that? Do you understand that? Please, each of you people, give me an answer from the chat panel. Do you understand that these two execution paths, this one and this one, these two cover or give us a complete statement coverage? Okay, each of you people give me an answer. If you all understand that, now I will say why this is not a full branch coverage criterion. Okay, so these two, let me also draw it. This one, okay, and this one, these two execution paths are sufficient for full, complete statement coverage, okay? But these two are not enough for the full or complete branch coverage criterion. Can someone tell me now why this is so? Can someone tell me why these two are not enough for the branch coverage, full branch coverage criterion? Exactly. Okay, thank you, Metehan. Well, here, these two don't cover this edge. So this edge is not executed yet. This edge is actually not tested yet. So that's why we need a third execution path to provide a full branch coverage criterion. Does everyone understand that? I would like a confirmation from each of you again that you understand the difference between the statement coverage criteria, full statement coverage criterion, and full branch coverage criterion. I would like each of you to answer through the chat panel that you understand that, or if you don't, please give me a question. Okay, so the execution paths I draw using the colors blue and red, does it also tell you why branch coverage subsumes the statement coverage criterion? Why complete branch coverage criterion subsumes, includes, contains the statement, full complete statement coverage criterion? Do you understand that too? Okay, great. Okay, let's continue with the okay, let's continue with the coverage criteria. These were branch statement and branch coverage criteria. And now let's go over this example. Now here, let's go back. Well, this is the control flow graph of the first example of the white box testing discussion. It is this one here. Okay, it is this one. And these here were the black box testing cases, black box test cases of this example. All right. Now, okay. Well, these here are the black box test cases. These here. All right. So, and well, black box test cases are, if you remember from the category partitioning testing, each of these are the typical representatives of the equivalence classes, right? Equivalence classes. So let's go back, if you like, to the example. Okay, we have to test using the well, these are each equivalence classes. All right, these are the open boundary equivalence classes, two of them, and this here is okay. This here is another equivalence class. All right. Uh, well, for these two, we use the test cases that is 1 less than 0, -1, 1 on boundary example equal to 0, and 1 within the set which is equal to 1. So -1, 0, 1 for this, I'm sorry, 99, 100, and 101, 101 for this. And these are the boundary examples. And another one, okay, another one is the 50, which is a very good equivalence class for the value for the equal. I'm sorry. This is a typical representative for the equivalence classes between 2 and 100. Okay. So, but we don't have a 10 here because we can't see the code. We don't have another test case for I equal to 10 because we don't see the code, and we have in hand a functionality for the software product which is supposed to find out the summation of the numbers of the integers up to a value of I. We don't include, of course, this I equal to 10 test case, all right? But since we can see that in the code, in the white box testing, we also include, and of course, since we have these only, not I equal to 10, we have a problem. We don't see this portion of the code. We don't test, I am sorry, we don't test this portion of the code, even if we have 1, 2, 3, 4, 5, 6, 7 test cases to test this code with. All right. Well, now let's go over what we did in the last time. Using these, what statement coverage do we get? First, let's do this again. Well, using these, for example, -1, since it lets us through this path, okay, we covered this one, we covered this one, we covered this one, okay. Using 0, also we covered these. Using 1, now we cover what? We go through this path, right? We go through this path with 1, okay? And then, well, if x is equal, okay, we go through this path. Since I is, let's say I is 1 and x is equal to 0, we first go through this path and then through this path, okay, and then through this path. So we cover all statements except this one. So each of these values cover all statements, all nodes here, except this node. So what does this give us as far as the statement coverage is concerned? Well, 90%, right? Why? Because we have 10 statements or 10 nodes here, but we have only 9 of them tested. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, junctions are excluded, and the begin and end nodes are excluded. Okay, so these give us 90% of statement coverage. These give us 90% of statement coverage. Why? Because we test all 9, but we don't get to test with this one, with these test cases. All right. So this gets us a 90% statement coverage. Now, do you understand that? Do you understand that the test cases for the black box testing gives us a 90% statement coverage and not a complete statement coverage criterion? Do you understand that? Do you have any questions? Do you have any questions on what some test cases let me phrase it in another way. Do you understand how a test case can test an execution path? Do you see that? And how this further contributes to to making up the statement coverage criterion? Okay. Well, now let's do the same thing for the branch coverage. Okay. Let's now show you, for example, for -1, when we go through the same execution path through this one. Okay, -1 covers through this execution path this one, this edge, this edge, this edge, and this edge. And all others, okay, 0, 2, 0 also covers these edges, all right? And 1, 50, 99, and 100, these cover all other edges here, all other edges, but except these two edges. So, well, when counting 1, 2, 3, 4, let's see, 1, 2, okay, let's check them with some, okay, 1, this one, oops, sorry, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Okay. So this, I don't count this since this is a part of this one which I counted, and since this is a part of this one, okay, I don't count this because this here is a portion of the whole edge of this edge. Okay, so I don't count that because I count that here once. So this makes 13. This makes 13, but I have 15, this one and this one too. So I have a total of 15 edges. So that covers all these here test cases, the black box test cases, give me only a branch coverage of 87%, which is 13 out of 15 edges. So these two edges, these ones, these are not tested using the black box test cases. Okay, so this gives me an 87% branch coverage. This is not a full coverage criterion again. So what do I need? Can someone now give me a single test case, that will make both the statement coverage and branch coverage criteria complete? Can you give me, each of you people, I would like each of you people to write me a test case from the chat panel that will make both the statement coverage and branch coverage criteria complete. I am expecting an answer from each of you people. Okay, I'm still waiting. I'm waiting for another minute for you to give me an answer. The question is, what test case should I add to the black box test cases here so that I get a full statement coverage criterion and a full branch coverage criterion, or complete? Any others? Any others who want to give an answer? Another 15 seconds. Okay, most of you people have answered correctly when they said I is equal to 10. Okay, what is missing in our both coverage criteria? This one, right? This path should be included. That means this statement or these two nodes should be included. And which test case lets us or makes us to test this path? I equal to 10, right? So when I is equal to 10, when the test case is equal to 10, then we can test this path. So that means I is equal to 10 should be the test case to stimulate, okay, to activate this execution path. So I is equal to 10 is the correct test case that will stimulate this execution path. Okay, so most of you people, most of you people that answered have answered correctly, which I am happy for. All right, now let's go back to okay. Well, this with this test case, I equal -1, I equal 1, and I equal 10. These are enough. These are enough to stimulate execution paths for all nodes and all edges, including also including also this execution path here. Only 3 test cases are enough as long as I is equal to 10 is included. Only 3 test cases are enough for a full statement coverage and for a full branch coverage. Okay, let's continue. Here, from our previous discussion, you have understood that branch coverage is not equal to statement coverage. Okay, branch coverage is not equal to statement coverage. Okay, I equal to 10 is a failure for this algorithm, all right, because it provides a summation value of 0 where I is equal to 10, where the sum of numbers or integers up to I equal to 10 doesn't give us a value of 0, of course. Okay, with this one here, with if I is not equal to 10, if I is not equal to 10, if this is true, then we go through this way. If I is equal to 10, if this is not true, then we go through this way. Now okay, we correct our error and we get rid of this statement here. All right, we correct our error. Now this time, without the test case I equal to 10, with only these 2 test cases, I cover, I have a branch coverage of 94%. Why is that? Now with 10 missing, with only these 2 test cases, I don't cover this one. I don't cover this one. So out of 14 edges, I only test 13, and I don't get to test this one with I equal 10 missing here. So I get a 94% branch coverage. Okay, but can someone tell me, or I not can someone tell me, but I expect from each of you people again an answer. I give you 2 minutes. I expect an answer from each of you people. What is the statement coverage in this case? What is the statement coverage in this case? With these 2 test cases, what is the percentage of the statement coverage that I attain, that I reach with these 2 test cases here? Okay, I expect an answer from each of you people. If you don't know, say don't know. But If you don't know, that means you don't understand it, then please ask your question, all right? What do the others say? Statement coverage, statement coverage. Okay, statement coverage. Okay, any other answers? Let's wait another 15 seconds. Statement coverage using these two test cases. Okay, well, with minus one, I covered these two, and with one, I cover all remaining ones, all of these. Okay, so that means I get a 100%, that is full statement coverage. Okay, and this is because, well, this edge here is not included, or an execution path including this edge is not activated. So that's why we have a 94% branch coverage. But since there is no node here, that is not stimulated using these two test cases. I'm sorry, yes, using these two test cases, we still have a full statement coverage. And this tells us that branch coverage is not equal to statement coverage. Okay? Well, this slide was the proof of this claim. Statement coverage is not equal to branch coverage, and we see this from this slide. Okay, do you understand what's going on here? Do you understand that this slide proves that statement coverage is not equal to branch coverage? Okay. Now let's continue. Let's continue with other coverage ideas that provide us with a stronger criterion. Let's define the condition coverage criterion now. A set P of execution paths satisfies the condition coverage criterion if and only if, for every control node in the flow graph consisting of atomic predicates C1, C2, etc., Cn, then each condition Ci yields true yes when evaluated within a path P1 in P, and Ci yields false no when evaluated within a path P2 in P, where I is from 1 to n inclusively. Okay, if this criterion is fulfilled, then we say that condition coverage criterion is fulfilled completely. Okay, well, here we're talking about an internal structure of composite control predicates taken into account. Like, for example, in this one, okay, let's go back to our example, if we may, for this one, for example. Okay, here we have I is less than 0 and I is greater than 100, and we have an we or these two conditions. Okay, we have two conditions. We have two conditions in this decision node. All right. So if we perform or if we use statement coverage, then it is enough for this node to be tested only once. All right. For example, using -1 only, I can test this statement. If I use, on the other hand, branch coverage criterion, then I have to test this edge and this edge separately. So that tells me that I have to go through this path once and through this path once. So branch coverage tells me that I need to use at least two test cases, one of which makes this composite condition true. Okay, and one of this makes this composite condition false. So leads me through this edge. So I less than 0 or I greater than 100. Well, -1, for example, makes this one true, and 1, for example, makes this one true. Okay, so this one, any one of these makes this okay for the statement coverage. Two of these, okay, let me show you here. Two of these makes branch coverage okay. This one, for example, makes the statement coverage okay. Okay, which test cases do you think makes this okay for the condition coverage? Let's go back, if we may. Let's go back to condition coverage criterion. Okay, a state P of execution paths satisfies the condition coverage criterion if and only if, for every control node in the flow graph consisting of atomic predicates, CI yields true when evaluated within a path, and CI yields false when evaluated within a path. So what does this tell us? Okay, well, we are at the end of this hour. So for tomorrow, please think of this. Think of this. Which one? Oops. Sorry. Which test case do I need to come up with a complete condition coverage criterion? All right. This is your exercise for tomorrow. Okay. I will see you tomorrow at 8:30. Thank you for your attention.